The title of our lesson today is Comparing Positive and Negative Numbers. So we have 3 learning targets. Number 1, I can use inequalities to compare positive and negative numbers. So once again, inequality symbols are these little symbols over here, right? They mean either greater than or less than. I can explain how to use the positions of numbers on a number line to compare them. So number lines are going to be a really important tool that we're going to use to decide whether a number is larger or smaller. And I can explain what a rational number is. So our first activity is which one doesn't belong, inequalities. So at this time, why don't you pause the video and try and decide out of these 4 inequalities, which one doesn't belong and why. So, looking at these now, at this point in the year, we've done a lot of these, which one doesn't belong, and it's always kind of the same idea that really you can find a reason why any of these 4 doesn't belong. So this first one is the only one with a fraction, so maybe you could say that one doesn't belong. This is the only one with 2 decimals. This is the only one that has 2 whole numbers, 10 and 100. So you could really make an argument for any of these why they don't belong. So once again, the idea here is just you looking closely at the numbers and trying to kind of think about what they represent. But the one I'm going to choose to focus on is this one. And why do you think I chose that one? This one really stood out to me. The reason is, if we were to read this, this says 8 and 5/10 is less than 7. Is 8 and 5/10 smaller than 7? It is not. So this is the only one that is false. Like that one is just straight up not right. The other ones are all correct. 10's less than 100, 8 and 5/10 is bigger than 9 and 5/100, and 5/4 is equivalent to 1.25 or 1 1/4, so that is less than 2. So once again, if you struggle with inequalities, I know it seems childish, but I still always think that it is helpful to imagine this as like an alligator or as Pac-Man or whatever, and whichever one his mouth is facing, that's the one he wants to eat because it's bigger. So honestly, I know it seems childish. If that helps you, please use it. Taught that to high schoolers, and it made a big difference for them. So it can make a big difference for you too. All right, so on to our next activity, comparing temperatures. So here are the low temperatures in degrees Celsius for a week in Anchorage, Alaska. So very cold there. So we need to plot the temperatures on a number line and which day of the week had the lowest temperature. So I can see that it goes 5 and negative 0.5. There's a 0 here. It's always kind of a good idea to put 0 on the number line, probably somewhere towards the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if there's 11, then in the middle would be 5 to the left and 5 to the right. So there's 0, and there's Sunday. Okay, all right, and now 5. So once again, positive numbers are to the right. So 1, 2, 3, 4, 5 would be over here. Negative 1, negatives are to the left. So here's my negative 1. Negative 5 and 5/10 or negative 5 1/2. So once again, negatives go to the left. So negative 1, negative 2, negative 3, negative 4, negative 5. And then it would be halfway to negative 6, right? In between negative 5 and negative 6. Thursday is negative 2, negative 1, negative 2. Put those points on them. And Friday is positive 3, so 1, 2, 3. And Saturday was 4. Okay, so there are my points on the number line. Once again, important to know, positives are to the right, It's also important to note that numbers get bigger the further to the right you go, and numbers get smaller as you go to the left. Okay, so I'm just going to add that little note there. Okay, and so the lowest number, if we're thinking that numbers get smaller as they go to the left, then -2 is smaller than -1, and -5 and 5/10 is the lowest temperature. That is the coldest temperature it can be. And if numbers always get larger to the right than 5 degrees, I should have degrees Celsius, would be the highest temperature. Okay. Now, the lowest temperature ever recorded in the United States was -62 degrees Celsius in Prospect Creek Camp, Alaska. The average temperature on Mars is about -55 degrees Celsius. So it got so cold one day in Alaska that it was colder than Mars, which is like millions of miles further away from the sun than us, and somehow it was still colder in Alaska on that day than the average temperature of Mars, which is kind of mind-blowing. Which is warmer, the coldest temperature recorded in the USA or the average temperature on Mars? Explain how you know and draw a number line to represent the situation. So I accidentally did just kind of say the answer. So once again, if we look at a number line, numbers get smaller as you go to the left. So -1, -2 is smaller than -1. -3 is smaller than -2. So -62 is actually less than -55. So for negatives, it's kind of like the opposite of positive numbers, right? Like the bigger the digit for a positive number, the larger it is. The bigger the digit for a negative number, the smaller it is. So maybe we could write that. For negatives means smaller or less. Okay, so that's important to note. And that's kind of also can be the explanation as to why it was colder in the USA that day. So, which is warmer? It was warmer on Mars than Alaska. Okay, because Mars, the average temperature on Mars is greater than, once again, we've got our little Pac-Man. He's eating the temperature on Mars because it is larger. And if we drew that on a number line, let's say 0's here. Here's -55. So once again, -1, -2, -3. So you're counting kind of like backwards in a way. And then so -55, and then -62 would be even farther away from 0. So it would be smaller. Oh, and here's where they wanted the inequality. C2, which we had already written. All right. On a winter day, the low temperature in Anchorage, Alaska was -21 degrees Celsius, and the low temperature in Minneapolis, Minnesota, was -14 degrees Celsius. Jada said, I know that 14 is less than 21. So -14 is also less than -21. This means that it was colder in Minneapolis than in Anchorage. Do you agree? So why don't you pause the video right now and state whether you agree or disagree, and why. So, let's think of our number line again. So if here's 0, we have -14 and -21. So negatives go to the left, -1, -2, -3, -4, 5, 6, 7, 8, 9, 10, -14, and then you would keep going, -15, -16, 17, 18, 19, negative 21. So, once again, the further to the left you go, the smaller the number is. So, we actually disagree. Because negative 21 is less than negative 14, so it was colder in Alaska, in Anchorage. Okay, so when we're thinking about distance from zero, for positive numbers, the further away from zero you are, the bigger it is. But for negatives, the further away from zero you are, the smaller the number is. So even though this digit is larger than 14, right? Like how Jada thought, well, 21 is bigger than 14. So negative 21 must be bigger than negative 14. No, negatives are the opposite. So the bigger the digit for the negative, negative 21, that is actually smaller than negative 14. As a matter of fact, to illustrate that point, negative 1,000 is way less than negative 1.